So this is in tutorial Tribology tutorial question 1c. So it's a reference back from question 1b, the calculations, and we calculate everything. So I would think that this question would say something like this. Alright, would you recommend surface engineering process to enhance the hardness of the plate? Alright, so if you think about it, your steel itself, alright, your steel ball is harder than the copper most probably. Alright, and therefore the hardness of the copper will actually contemplate, and will cause this shaft. Most probably I think this is the shaft, or this is the plate, I also don't know, but any of the case, it will this I think this plate, yeah, most probably this plate lah. So this in between is the shaft, alright, while the red color one that I've shaded is the plate, I think. Okay, but nonetheless, let's come back here. Alright, so in order to because the steel ball is harder than the plate itself, alright, and therefore we need to ensure that the copper can resist the steel hardens, because the steel is really hard. So if you have a soft one, then the steel will eat into the copper and break the copper. So you want to enhance the copper's surface, alright, and therefore we will say that yes. In fact, the lecturer never say yes or no, so I think yes. Alright, we need to enhance. It's because of the steel is harder than the copper. Alright, yeah, because steel is harder than copper, and with what am I writing? And will wear off. This is will, and will wear off the surface of the copper easily. Alright, and therefore we need to enhance the copper's hardness, and therefore in order to do that, we will recommend the what's we call the transformation hardening process. If you remember our question 1a, we talk about it. Alright, so you will heat up your material. Alright, maybe this is the surface. You heat up this surface, alright, and change it to an austenite, where I think you know what I mean. So this is the some heat temperature thing, and the austenite region is somewhere over here. Alright, austenite region. So if you were to cool quickly, right, it will become martensite. Martensite is a very strong type substance. So therefore, yeah, so you want to heat it very fast. So the transformation hardening process is you heat the thing very fast and cool it very fast, or I should say that you heat it and then you cool it very fast. If you cool it very fast, then it's a martensite structure, which is very strong. Okay, hopefully you are clear, and therefore yeah. So if you want to read more, or you can just check it out, the 1a question, or if you want to read more, you can go to slide 36. Alright, then transformation hardening, you can read it yourself. I think this is it lah. Alright, nothing much happening. Alright, so I think I can just type down the answer in case that you want the answer from the lecturer. Give me a while. Yeah, a possible process is transformation hardening, which change the possible layer, the surface layer, to a martensite microstructure through hardening tempering, and therefore I think this is it. So yeah.